Alright, so this is the video for equilateral triangles. It's very similar to the isosceles one, except it's a tad bit easier because instead of two, basically everything is the same, right? You have three congruent sides, three congruent angles. Okay, so it's a little bit easier. Your equations are going to be a little bit more straightforward, okay? So the first thing what I want you to do is, well, since everything is congruent to each other, right? The angles are all the same, and then the side measurements are all the same as well. What is an angle equal to then in an equilateral triangle, right? So what is the actual number? So go ahead, think about it, see if you can figure it out by yourself. Okay, you have three angles that are the same in a triangle in order for it to be considered an equilateral. So if you're trying it, I hope you went ahead and you thought about, well, since all of them are the same, we can go ahead and you can guess and check numbers if you want, but really if you just let all of them equal to x, then we can go ahead and create this really basic equation that says, three x's together. I know it's a triangle, and we already know a triangle, if we add up all the angles, it always has to equal to 180, and that's from a previous video. And so we know that this is 3x is equal to 180, and then we can go ahead and divide by 3, basically just isolating the variable, and x is equal to 60 degrees. So this is really nice to know because you don't really have to memorize the fact that it's 60, right? You can do this every single time in your head, and it's very, very straightforward. Okay, so if you're working with an equilateral triangle, the angles always have to equal 60 degrees for every single one of them. So if we go over here to this one here, ignore that equation for right now. Let's go ahead and let's read the directions. So determine the length of DE. So we actually want to know what is this equal to. Okay. So the really nice part about it is look at the angles. They all have one line. Think of it as like one tick mark. And so what that means is that everything is equal to each other because you're automatically working with an equilateral triangle. Okay, so that right there is what you need to look for, right? Either three angles being the same or three sides being the same. And then you can go ahead and assume the other one. Okay, so what we can do now is, well, we know that if all the sides are equal to, and I'm trying to figure out this side, well, all I have to really do is just figure out what x is equal to and then plug it in. And that's where this equation comes into play. Because since the sides are all equal to each other, that means 5x minus 12 has to be the same thing as 3x minus 2. And now we can go ahead and we can solve the equation, right, by isolating the variable on one side. And so this is equal to 0, right? And we could bring it down. We get negative 4. 5x minus 3x is 2x. And then we can go ahead and do plus 12 on both sides. We get 2x is equal to 8. And then we can go ahead and divide by 2. And so then x is equal to 4. Now, you have to be careful though, right? Because the question isn't saying solve for x. The question is saying what is determine the length of DE. So we're going to use this though. Of course, we're going to use the x equals 4. We're going to use it to plug back in. Okay. So what I'm going to go ahead and do is you can plug into whichever one you want. You can plug into either 3x minus 4 or 5x minus 12. It doesn't matter because you're going to get the same answer anyways since they're all congruent. So I'm going to go ahead and plug into the 3x minus 4. So it'll be 3 parentheses 4 because that's the x, and then minus 4. 3 times 4 is 12. 12 minus 4 is equal to 8. So what that means is 3x minus 4 is equal to 8. But now since we're working with an equilateral, that means this is equal to 8 as well. And this is also equal to 8. And you can easily check it, right? 5 times 4 is 20. 20 minus 12 is 8. So everything works out. And so then there you go, right? Remember, the problem states determine the length of DE, which we just realized it's equal to 8. And that there is our final answer. Okay? So we're going to go ahead and move on to the next problem. Okay, let's go ahead with the next example. Go ahead, pause the video and see if you can figure this out. We're going to go ahead and solve for either x or y first, and then we're going to see how it actually works out. Okay, so the perimeter is 54. So what this means is if I add all sides, I know that it's going to have to equal to 54. But for right now, I want you to notice one really quick thing in your diagram. You only have two congruent angles. We don't have three, so we cannot assume this is an equilateral. All we know is that you have two congruent angles. So what you also have is two congruent sides, okay? So you can go ahead and it won't be wrong if this here is also 4x, okay? Since they're congruent. But the only thing you don't know is this side here. I know some of you are probably thinking, well, isn't it also 4x? As of this moment, based off of the picture, the diagram, and what we have, we don't know that. So what that means is I'm going to go ahead and skip x, and I'm going to see if I can figure out y. So if you notice, y deals with the angles. So it's a triangle, so we know it has to equal to 180. And we know two of them already. It's equal to 60 and 60, okay? So some of you could probably solve this already really quickly, and, good for you. You already know the answer y is. So move on and see if you can do x. So we would go ahead and do 120 plus y equals 180. And then we subtract 120 on both sides. And then there you go. Y is equal to 60. Now, because y is equal to 60, we now know that, yes, this triangle is actually an equilateral. Okay, we didn't know that before. You cannot assume it. I know you want to, but you cannot assume it unless you've already shown it. So we have three sides here, and we know the perimeter. So we can go ahead and we go back, and we can actually solve now for x because we know all three sides. Notice how I didn't include this 4x before because I just didn't know. Don't assume, okay? And so that there gives me for a 12x equals 54. Then I can go ahead and I divide by 12 because I'm isolating the variable. And I believe that is, I think, either 3.5 or 4.5. I really don't remember. 4.5. Okay. And so there you go. You have your two answers. 60 degrees and 4.5. It doesn't tell us a unit, so it's just 4.5. Okay. So let's go ahead with the next one. Looking at this here, you can do this pretty quickly. Some of you can. For those of you guys that can't, go ahead and let's just, take it one step at a time. And so we have 4x for one of the angles. We have y out here, okay? So then we see the 3 tick marks. So that means automatically we can assume this is an equilateral. So that means all of these angles are 4x, okay? So you can form two different types of equations. You can say, if I add all the angles inside this triangle, it's equal to 180. Or you can say, hey, I know if it's an equilateral, every single angle is equal to 60, which personally I think this one is easier, so this is the one I'm going to solve. Now, if you want to, you can solve this equation up here on the top, and it'll give you the exact same answer, okay? So if you do this, I believe that the answer is 15. Now, you can go ahead and use this information to try to help you out to figure out why. So what I'm going to do is I'm going to zoom in to that part right there. So there goes a straight line, there goes this, here goes y. And now here inside, I can go ahead and put 4x, which I know it's completely correct, but I already know what it's actually supposed to equal to. So go ahead and use that number. It's supposed to equal to 60. Now, if you don't know where that came from, it basically comes from this equation here saying, well, the angle for x is equal to 60. Now, for those of you guys that can see it already, you're looking for y, which is the angle on the right, which is outside the triangle. And so we know that this here is a linear pair. Since it's a linear pair, that means they equal to 180 when you add them together. Once again, some of you might not have to do this, and that's fine, good for you. But for those of you that need it, right, this is how you would get your answer algebraically. And so then that's how you know that the answer for y is equal to 120. And then there you go, okay? So that there is going to be the last example we do that has to do with algebra. Let's go ahead to go to this other question here, where for some of you it's going to be a little bit hard because just of how it's worded, but you just need to really think about what it's saying. So you're talking about definitions, so you got to go back to the basics. Is an equilateral triangle also an isosceles? So this here is your given. So you're given an equilateral triangle. So that means everything is basically congruent. What the question is saying is that, can we say this is an isosceles? Okay, so let's think about what the definition of an isosceles is. So you have two congruent sides, and then you have two congruent angles. Now, if you go back to the isosceles video, I didn't just say it has two, I said it has to have at least two. What this means is that you can have more, but you need to have minimum two. So if you notice, based off of this equilateral diagram, do I have the two sides? Well, yes, I do, because I just highlighted them. And then do I have two congruent angles? But you got to be careful now which ones I'm going to highlight, because it's really important. You know, for an isosceles, the sides and the angles, they're opposite each other. So technically, this angle is this angle. So based off of my yellow highlighting and blue highlighting, we can go ahead and we can answer this question. Yes. Okay. Yes, because you have the needed things to for it to be considered an isosceles. Now for the next part, I'm basically just going to switch it. So now I'm saying you have an isosceles. Does that mean you also have an equilateral? So I'm going to draw my given, which is an isosceles. Now the question is saying, is this also equilateral? Notice how all I did was just change the position of the two words. That's all I did. But the question makes it very different. So equilateral, by definition, you have three congruent sides. And then you also have three congruent angles. Now, obviously, most of us can notice this is going to be a no, right? Is an isosceles also an equilateral? No, because you just don't know anything about either the last side or the last angle. But the real answer for this one is going to be actually sometimes. Because in some situations, you will have that an isosceles is also an equilateral. Say, for instance, if you have 60 and 60 for the angles, then automatically it's also an equilateral. But instead of having 60, let's say you have, let's say 80 and 80. Right? So 80 and 80 is 160. So that means that this one up here is 20. So you see there, you have an isosceles that is not considered to be an equilateral. These type of questions are a little bit hard to wrap your mind around, especially if you really don't understand the basic definitions. And that's okay for right now. Once we get to, once you guys get to like different levels of geometry and shapes, that's where you would get these type of questions more, you know, like comparing squares and rectangles and things like that. Okay, so the next video is going to be examples where we have a mix now of both isosceles and equilateral, okay?